Okay, everyone, how's it going? We're going to continue with our Chapter 7 exam, and we're going to look at questions 4, 5, and 6. So here we go with question 4. In a large population, 40% of the households own VCRs. We're then going to take a random sample of 100 households to be contacted, and then we're going to compute a sample proportion. We don't know what that sample proportion is going to be. We know the parameter value is 0.46, but we don't know what the sample is going to be. So right now we're supposed to figure out the standard deviation of the sampling distribution. And then for this to work, we have to make sure that we are following the 10% rule. So 10% rule is the sample size n needs to be less than 10% of the population n. Well, we don't know the population n. We're just told that this is a large population. So we'll assume it's going to be true. All right. If I'm a student, I'm going to have to write something like, since the population is large, we'll assume the 10% rule holds. Okay, so now that we got that out of the way, we're going to go ahead and compute this. We did the formula in class, how that formula came to be. So we can just do the formula. So the formula is sigma p hat equals the square root of p multiplied by 1 minus p, the whole thing divided by n. We'll put our numbers in here. P is 0.46. The complement of that is 0.54. Divide that by the sample size of 100. And then we'll get our answer. So let me grab a calculator, and then we'll compute this. 0.54. Sorry, 0.46. What did I just do? The square root of 0.46 times 0.54 divided by 100. That gets us a value of 0.498. 0.498. So that is the standard deviation of our sampling distribution for the proportion. Number 5, in a large population of adults, the mean IQ is 112 and a standard deviation of 20. So these are parameter values. Parameter values. I can tell because those values are not coming from a sample, they're coming from the large population. So suppose 200 adults are randomly selected for a market research plan. This over here tells me n equals 200. Okay, we're supposed to describe this distribution. So we're going to go through everything that we've done. The shape is going to be approximately normal. And we can say that's true because 200 is greater than or equal to 30. That is the central limit theorem. Okay. Center. The equation that you might have remembered was that the center of the sampling distribution for x bar is equal to the mu of the population. The mu of the population is 112, so then the center of our sampling distribution is also 112. And finally, for variability, sigma x bar is going to be equal to the sigma of the population divided by the square root of the sample size. That's that inverse square root relationship we were talking about in class so much. So what do we have for sigma? Sigma is 20. What do we have for the sample size? Sample size is 200. We'll compute that real quick. It's 20 over root 200. 20 divided by the square root of 200. That gives me 1.414. 1.414. That's equal to 1.414. Just taking a look at how many of those digits you really need to carry. Over here, this is rounded to the nearest whole number, so really 1.4 is good enough for this. If you want to leave more than 1.4, then of course, no one's going to be too upset at you, but I think 1.4 is certainly sufficient enough for this problem. Okay, let's take a look at number 6, which is the last one we're going to do in this set. We've got, we're planning on taking an SRS from a population. If we double the sample size, then we're going to be multiplied by, and this is one of those things where either you kind of remember it or you don't really remember it, but in all cases, let's take a look at our sample standard deviation for x bar. That's equal to sigma over root n, and if we double the sample size, what we're really doing is we're just changing that to a 2n, so sigma over square root of 2n. And you don't really need to remember a whole lot. I mean, there's definitely some mathematics that you can do here, like that. But what you should remember is that whenever you double the sample size, or whatever you triple the sample size, you're going to change the variability, the sigma x bar, by a factor of 1 over square root of whatever that factor is. In this case, it's 2. So we are going to multiply sigma x bar by 1 over square root of 2, which is b here. Okay, so that's 4, 5, and 6. We'll see you for the next set.